What's up everybody? Welcome back to another episode of Modern Hobbyist. Today I'm going to show you how I made smart LED hexagon panels for my wall. Let's get started. Welcome back everybody, I'm Charlie with Modern Hobbyist. Before we get started, if you don't want to miss any of my new videos, then make sure to subscribe to my channel and click that bell icon so you get notified every time I upload a new video. Today's project isn't necessarily anything new. In fact, you've probably seen name brand versions or even do-it-yourself versions of this project before. But I'm still super excited about mine because I made it from scratch and I've already got several ideas for the next version of this project. Basically what I made is a series of hexagon-shaped LED panels that mount onto my wall and can be controlled using either the Blink app or by commanding them with Alexa. For Mark 1 of this project, I wanted to keep it simple, so I used a strip of WS2811 LEDs that are controlled by an ESP32 development module. The Blink library, along with the FOMO library, allow me to control the LEDs using the Blink app and Alexa respectively. The LEDs themselves run off of 12 volts, so I grabbed a 12 volt 5 amp power supply off of Amazon. The ESP32 development module has an input voltage between 7 and 12 volts, so I also bought some adjustable buck converters to drop the voltage to the ESP module down a little bit just to be safe. Now this step isn't necessary, but I have had an ESP module burn out before from a pretty reliable 12 volt power supply, so I didn't want to risk having that happen again. The ESP modules are relatively cheap though, so burning one out won't exactly break the bank. For the hex panels, I wanted them to be modular so that I could mount them one at a time, and I wanted the light diffuser to be detachable so I could access the electronics without taking the panels down from the wall. So using Fusion 360, I designed a base for the hexagons that will hold all the LEDs. Each hexagon has small tabs of support material on each side that can be broken off to pass the wires through to connect the LEDs together. There's a small slot on each side for the diffuser to snap into so it can be quickly and easily removed from the base. I also created a copy of the base and modified it so that one side had a hole for the 12 volt power input to mount into. Next, I designed the faceplates for each hexagon to act as a diffuser for the LEDs. Each faceplate is thin enough to let a good portion of the light escape and thick enough to evenly distribute the light so you can't see the individual LEDs. Now to actually build this thing, I started by printing out all of the hex panels and diffusers. Everything is printed out of white PLA, which I found does a nice job of diffusing the LEDs, but the bases don't need to necessarily be printed from white PLA. It just happened to be what I had on hand at the time, so that's what I used. With everything printed out, I grabbed the LED strip to start installing them into the bases. The WS2811 LEDs can be cut into sections of 3 LEDs each, and each hexagon holds 7 sections which are installed around the wall of the base. So after cutting the LEDs into strips containing 7 sets of 3 LEDs each, I soldered some LED strip connectors to each end of the strip so I could connect each hex together to form one continuous string of LEDs. While soldering, I made sure that the connectors were in the correct side of the strip so that they could connect together in the right direction. I don't think it matters which connector is in and which is out, so I just picked one and made sure it was consistent throughout the entire strip. With the connectors soldered on, I installed the LED strips into the base of each hexagon using the adhesive on the back of the strip. If the adhesive doesn't seem to be enough to hold the strip in, you can add a dab of super glue to help secure it. Each side of the hexagon has a slot at the bottom to feed the LED connectors through, but I printed it with support material so that the slot is hidden by default. After planning the layout of my hexagons, I broke the support material off in the spots that the cables will be fed through. And then with all the slave hex panels assembled, it's time to start working on the master hex panel. As I mentioned before, this project uses the Blink library to allow it to be controlled through the Blink app, and it also uses the FOMO library to make it Alexa compatible. For this code to work, you'll need to update the configuration.h file with your Wi-Fi credentials, as well as the auth code generated by the project you'll have to create in the Blink app. If you want a walkthrough of how to get my code uploaded to the ESP32, Either check out my video I made on the subscription counter or check the description for links to some documentation. Once the code was uploaded to the ESP32, I soldered the data pin on the LED strip to pin 27 on the ESP32. Next, I connected the LED strip and the voltage regulator to the output of the 12-volt power jack and used the voltage regulator's onboard potentiometer to set the output to 7 volts. Lastly, I soldered the VIN and ground on the ESP32 to the output of the voltage regulator to give power to the ESP module. So, with all the electronics soldered together, I mounted them into the master hex panel with double-sided tape and installed the LED section the same way I did for the other hexes. For the master panel, make sure that the electronics are sitting as flat as you can, otherwise you'll see a shadow on the faceplate which could throw off the whole look of that hex panel. Finally, with all the hexes assembled individually, I mounted them to the wall with double-sided tape in the pattern that I had drawn out ahead of time. While I was hanging each hex onto the wall, I connected it to the previous hex before sticking it down so that I could handle the wires a little bit easier. Once all the panels were mounted onto the wall, I did a little cable management where necessary to keep the wires out of the way of the LEDs and to keep them from casting any shadows. I then plugged everything in to do one last check before mounting all the diffusers and turning off the lights to check out my final result. To control the hex panels with my phone, I configured one of the virtual inputs in the Blink app as this funky little RGB color picker, which the ESP module reads to set the LEDs accordingly. I also added a switch button so that I could change the hexagons between 3 pre-configured modes. And after having Alexa scan for new devices, I can turn them on and off with the rest of the lights in my office. And that's it. That's how I made my LED hexagon panels Mark I. In the future, I plan to make each hex panel smart by adding Arduino Nanos inside of them, so I can set the color of each hex panel individually or program them to music or something. I also plan on replacing the LED wire connectors with spring compression contacts so the panels can be arranged in any order without having to mess with wire connectors. But for now, I just wanted to get something up on my wall as soon as possible to help improve the background of my videos, and I really like the way that these turned out. Now you might be asking yourself, why the heck are 2 of the hex panels different colors? And that is a very good question. You see, while I was starting this build, I was using a strip of LEDs that I originally got off AliExpress for the YouTube subscription counter that I made, which, by the way, you should check out if you haven't yet. Anyways, since I used this strip for my subscription counter, I didn't quite have enough LEDs to finish all the hex panels, so I ordered another strip off AliExpress. However, since the new strip was shipping from China, and given the current state of the world, it wasn't going to arrive for almost 2 months. So being as impatient as I am, I decided to order a strip from Amazon for the time being. I figured I can always use more LEDs, and who knows, by the time the LED strip gets here from China, I may have used all the Amazon ones already. Well, it turns out that the manufacturers of these LED strips sometimes use different protocols when it comes to the order that the 3 colors that make up each LED pixel, red, green, and blue, are defined. For example, the original LED strip expected the data to be in the order green, red, blue. So the Arduino code that I wrote was originally configured to handle LEDs with this protocol. However, the Amazon strip expected the data to be in the order blue, red, green. So if I tell the ESP module to turn the LEDs blue from the Blink app, the data being sent to the beginning of the LED strip will look something like this. When that data array reaches the Amazon LEDs, they will think that I'm setting the green LED to full brightness. So pretty much every color is going to be wrong, except for the colors with the same amount of green and blue. I haven't received the new strip from AliExpress yet, so I haven't been able to fix those 2 panels, but it's not a huge deal because this whole thing still looks pretty cool, and if I set the hex panels to random colors, you can't even tell that they're wrong. When the new strip gets here, I'll replace the mismatched ones, but in the meantime, I thought I'd get this video out so that I can share my creation with you and also share that little tidbit so that you know to always buy your LEDs from the same manufacturer. That's all for this one though. Let me know in the comments what you thought of this project, or if you have any video ideas for me to make. Also, be sure to smash that like button and subscribe to my channel if you want to see more videos like this. Otherwise, that's all for now. Thanks for watching, and I'll see you guys in the next one.